Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined by Dr. Ryutaro Uchiyama. He is Research Fellow at Nanyang Technological University in Singapore. His research interests include cultural evolution, cognitive plasticity, and developmental psychobiology. And today we're going to focus mostly on his PhD thesis, Cultural Evolutionary Production of Human Psychobiological Variation and Function, and a paper, Cultural Evolution of Genetic Heritability. So, Ryutaro, welcome to the show. It's a pleasure to have you on.
Yeah, thank you very much for inviting me to your YouTube series. It's an honor.
Thank you so much. So, let's start perhaps. Tell us first about the framework you use in your thesis and paper. What is cultural psychobiology?
Okay, so there's a field called cultural evolution. I think many of the guests that you have had on your show are proponents of this field. You've
Yeah.
had some of the pioneers like Joe Henrik. Also, my PhD supervisor, Michael Musukrishna, has been on your show. These people have been working on a framework that originates from anthropology that tries to understand what is unique about the human phenotype, about human behavior that distinguishes us from other species. There is contiguity, of course, that is important, but at the same time, there is some kind of discontinuity. And so cultural evolution is to try to understand how culture itself, so these socially learned traits like technologies, social norms, institutions, beliefs, ideas, how these can be understood as an evolutionary dynamic that is analogous to genetic evolution, but differs also in interesting ways. So that's cultural evolution. So this is kind of a population level, sort of high level model of how human societies work, how they change over time. At the same time, of course, there's this whole other area of behavioral science, including psychology, economics, sociology, and so on. And within that, there's a subfield that studies the biological basis of human behavior. And so I'm referring to this as psychobiology. It's a bit of an old-fashioned term. I think it's so psychobiology or biopsychology. It can go either way. I think it's been superseded by the term behavioral neuroscientists, behavioral neuroscience. So I think at one point the psychobiologists rebranded themselves as behavioral neuroscience. It maybe for funding reasons, maybe for the prestige that comes with kind of looking at more low-level anatomy and physiology. I understand that. My background is also in the brain, so I'm all for that. But at the same time, there's kind of a conceptual assumption that the brain is enough to understand behavior. So it's kind of reducing biology to the brain. Of course, these people also look at things like genes and hormones and such. But it's a certain kind of a bet. It's a gambit. But I'm kind of pulling back. I'm saying, okay, actually, in order to understand human behavior, you need to have a more integrative approach that is not just looking at the brain. It's looking at the environment, which I guess we'll talk about. And this environment is a cultural environment. That changes in very systematic ways, that dispenses certain resources, both material and informational. And so that kind of leads to a natural interface between the science of human behavior and cultural evolution. Cultural evolution itself is a bit abstract. It often does not talk about the details of human behavior or the mechanisms of, about at the individual level. So when I say cultural psychobiology, I'm just trying to put out a simple term that merges these two. I don't necessarily think of it as a field in itself. It's just kind of a motto, I guess, for my PhD. So that's what cultural psychobiology is.
And so culture would also be part of the biological basis of the human mind. I mean, not just brain or genes as people usually think about, right?
Yes, so it cannot be viewed as an input to a more fundamental substrate. It is itself a part of this fundamental integrated system that includes society and the individual's organs and body.
So, and I mean, with all of that in mind, and talking about behavior genetics specifically, what would you say are the aspects of behavior genetics that are important to consider in a discussion about how heritability might be influenced by cultural evolution?
Okay, so there are some aspects of behavior genetics, and I think you've also had many behavioral geneticists
Yeah.
on your show. Yeah, so it's kind of an interesting field. It's been around for a long time, as you know. Um, okay, a few key points. One is that in behavioral genetics, at least on my reading, there's no fundamental distinction between humans and non-humans. Let's not even say fundamental. There's no no kind of not even a notch between them. They can be considered, of course, like behavioral geneticists usually study humans. That's sort of implicit in that phrase. But in principle, it should be applicable just as much to non-human species. That framework, of course, I think there are people doing GWAS on many species. I'm not that familiar with the literature, but there is that contiguity. So I think once you take human culture into account, you do have to think about different processes that distinguish human genetics and sort of the system surrounding the genes that is not present in other animals. Another key idea is that the variability of the environment, which is, of course, when you talk about heritability, it's something you need to think about. It's shaped by cultural transmission. So, this is sort of the other side of the coin of what I was just talking about. So what is it? It's cultural transmission. Information and knowledge and behavior that is coming through social learning. And this is itself shaping the variability of the environment. And if you want to talk about something like heritability, you need to think about culture. Finally, I think that behavioral genetics has a certain root in human intuition and also probably our intellectual traditions. So, the philosophical tradition of the West. I'm not a professional philosopher myself. I read a bit in university and such, but I believe there is this strong orientation toward the individual. If it's Descartes, it's the cogito. You have this agent who is perceiving the world, and even if you talk about action, it's still at the level of the individual. Mm-hmm. And I think, also about environments as well, sort of our intuitions and also our philosophical traditions, thinking about the environment. It's really thinking at the sort of the level of what we observe during our lifetimes. So, we observe some change during our lifetimes, and we say, oh, okay, so there are this kind of environment, that kind of environment. I've been to this continent. I've seen other cultures. A lot has changed during my lifespan. But of course, that's a very limited view from the cultural timescale, which spans, hundreds or thousands or even longer years, right? And so we're a bit biased by our myopia in terms of time span. And I think behavioral genetics is influenced by this, and it doesn't really have a conception of how environments really change over these long time spans that are beyond human observation, at least at the intuitive, everyday level.
Mm-hmm. But with your cultural psychobiology framework in mind, would it change anything about how we understand the concept of heritability, for example?
Yes. So heritability, of course, this has been a topic of much discussion for decades. So heritability, of course, it's the variance in phenotype that is explained by genetic variance. Mm-hmm. And you can measure this. Traditionally, it's been through twin studies, comparing identical twins with fraternal twins, and then looking at the concordances and such. But of course, heritability, there's the variance in phenotype explained by genes. There's a variance in phenotype explained by environment. And there's been a lot of work done, needless to say, on how genes work, how they are expressed, how they recombine, how they change over generations, how they mutate, and so on. But there hasn't really been a similar program for studying and analyzing the organization and dynamics of the environment. There are sort of big data approaches, sometimes called exposome analysis. They go by many names. That is, let's just collect everything about pollution, about education, and just kind of mash everything together and then see what comes out. And you use advanced statistics for that. But that's kind of a pre-theoretical way of approaching it. And there isn't really a theoretical machinery that's akin to what genetics has and evolutionary biology has in the environment. And so cultural evolution fills in part of this whole. And so that is why it will change, because it influences the environment component of phenotypic variance. That's why it's needed for understanding heritability.
And how can culture influence genetic effects?
So a genetic effect, of course, is not something that is a function of just the gene. Like I said, you also need to think about the environment, right? So, okay, one example that we give in our paper, and just to advertise the paper, so this is a paper that's in press right now at Behavioral and Brain Sciences. So it is me, Rachel Spicer, and Michael Musukrishna. We're the three co-authors, and then we have 29 commentaries given by researchers in various fields, and then we have written the response, and this whole package will be coming out hopefully soon. I'm estimating around September. Let's see. In any case, one of the examples that we give in this paper is UV, so ultraviolet rays coming from the sun, and how it interacts with skin, and how it interacts with different levels of pigmentation of the skin. So, of course, people with darker skin are able to protect their skin from UV better, and people with darker skin usually have ancestries in areas of the world that have historically had more sunlight. So this is generally considered a genetic adaptation to UV. But whereas in colder regions that have less sun, now the problem becomes if you don't get enough sunlight, then you get vitamin D deficiency. And so you need lighter pigmentation in order to absorb the sunlight. So there's kind of a middle ground, and it depends on the context, the ecological context, what the optimal level of pigmentation is. Of course, there's a lot of complexities in that, but that's the general gist of it, right? Then, of course, you have genes that are associated with level of pigmentation. You know, this has been studied pretty well. It's not really omnigenic. It could be, but you know, there are a few genes that explain a lot of the variance in pigmentation. So now, you know, you can say, okay, so this pigmentation, this gene is associated with pigmentation, and in a place like Australia, it would be associated with skin cancer. So we do see that people who have European ancestry in Australia do need a lot of sunscreen because they have tended to have high rates of skin cancer compared to people who have darker skin. Okay, so now we know that this gene is associated with pigmentation. It's also associated with skin cancer. So you know, if we're interested in skin cancer, then maybe we can call this a skin cancer gene. You know, even if we know it has other functions as well. But actually, this gene, the effect of this gene is influenced by many things. One of which, of course, is ecology. You know, if I'm in northern Scotland that doesn't get so much sun, or or Norway, say, then this gene predicts skin cancer to a much smaller degree, right? Because just simply by fact that I'm much less likely to get skin cancer. At the same time, it's also influenced by things that are not ecology, like sunscreen. So I already mentioned that sunscreen protects against skin cancer. So in a society with sunscreen, where everyone is applying it in the proper way, compared to a society that has no sunscreen, in the society with the sunscreen, this gene also predicts skin cancer to a less degree. So the genetic effect of this pigmentation gene in predicting skin cancer varies depending on both ecology, okay, so let's just say latitude for now, and also the diffusion of practices like using sunscreen, also how much time you spend indoors, even the kind of foods you eat. So for example, a Mediterranean food, it's known that it contains high levels of nutrients that protect against oxidation, and so this also protects against skin cancer. So there's diet, the fact that some societies have a lot of office work that are indoors during certain times of day. So these are all cultural practices, right? These are not part of the natural world as it exists if humans were not here. These have been transmitted down generations. So sorry that it's getting a bit long, but to sort of just give the gist of this, both culture and ecology change the genetic effect. And culture is changing much more rapidly than ecology. I think people can generally understand this. It is a bit scary how ecology is changing rapidly now due to climate change. But nonetheless, culture has So cultural evolution, the whole field is premised on the idea that culture changes much more fast, gives much more rapid adaptations than the slow pace of genetic evolution, and so that's why it became such a powerful tool for humans. That's how culture can change genetic effects.
Mm-hmm. But behavior geneticists divide the environment between the shared environment and the non-shared environment. Is it that culture fit into any of those two categories? For example, the non-shared environment, or is that not even the correct way of thinking about it?
So I think it's kind of a tricky question. I think it relates to both. So of course the shared environment is the household. Well, at least that's sort of how it's used statistically. So twins in the same household usually, and it does. Okay, where should we start? The non-cultural, the non-shared environment is interesting because I can start with an example. Okay, it's kind of a big topic, and I don't really know where to start. So as an example, okay, so the heritability of intelligence. Okay, so this might be something we talk about later anyway.
Yeah.
So there's this thing called the Scar-Row effect. So the Scar-Row effect is when the heritability of high SES, high socioeconomic status households, who have better levels of education, richer, and so on, is higher than low SES households. And so this is it's well known, and it's prominent in societies like the U.S. And to a lesser degree in places like Europe and Australia. And so the U.S. of course has greater inequality as measured by things like the Gini coefficient than most European countries, and so it's probably associated with this. And so historically, it's been understood as so maybe it's that so people in high SES households are able to realize their genetic potential more, and it's with the many nutritional and pollution related insults in low SES households and not enough opportunity for education, the genetic potential is realized to a lesser degree. So we find this. Okay, so high SES, higher heritability. But then when you look in the rodent literature, there's this one paper. I think sorry, I can't remember the first author's name, but it's cited in my paper that's coming out soon. So they find that in mice, there's often this type of experiment called an enrichment experiment, where they compare mice that grew up in an impoverished environment where not many things, not many objects to manipulate, not many different things to explore, and so on, and an enriched environment that is just many more things going on, many more types of behavior that can develop in these environments. This has been around for a long time. But when you compare the heritability of the mouse version of general intelligence, which is sort of, if you do a factor analysis over different kinds of cognitive tasks that mice can do, you also get this general factor. The heritability of mouse intelligence is lower in enriched environments and higher in impoverished environments. So this sort of makes sense in itself, because in enriched environments, there are more possibilities of behavior, and the developmental trajectory has many more possibilities, right, to move around. So the environment exerts a greater influence on development of things like intelligence. And then so this corresponds to the non-shared environment, so which is the individual's experience that is not shared by its siblings if it was a human household. But okay, so that makes sense, right? There's more ways that the developmental trajectory can change in this mouse enriched environment. But then why do we see the opposite in humans? Okay, why do we see the opposite heritability pattern in humans, the interaction? So even if a mouse develops some, has some amazing developmental trajectory and actually becomes this, finds its way into this niche where it becomes this, navigational genius, or maybe it's amazing at manipulating things and it just gets better and better. And so you can have these development of skill, right? but the mice do have social learning, but to much lesser degree than humans. And so it does not transmit across the community in that environment, right? Whereas in humans, so in humans, because there's cultural learning, when one individual develops some novel behavior and so on, it transmits across the group. What one prediction or a kind of a analysis in this of this inversion that we have in the paper is that in humans, because of cultural learning, that's what's creating the Scar-Row effect in part. And then it's why you see the inverted pattern in mice. And so this is how culture can impact this space of the non-shared environment. So whatever happens in this non-shared environment, the way it influences variance in phenotype, this diffuses in human societies throughout the society, whereas it does not in the mouse society.
Mm-hmm. So another question, what aspects of cultural dynamics explain gene-environment interactions?
Yeah, so gene-environment interaction, the example we can use is the skin cancer and pigmentation example that I just gave, right? So yeah, if there's a gene for pigmentation, then its effect will depend on the environment. And then, the common way to represent this is with a reaction norm. So you might have in x-axis, that's it could be something like latitude, right? Or amount of sunlight over the course of the year. And then you'll have the y-axis will be the phenotype. So let's say skin cancer risk, right? And then skin cancer risk changes depending on where you are. And then yeah. So okay, so we have this interaction between the environment and the gene, and so this is very well known. But what's less well understood is that in human culture, cultural innovations are always acting upon this interaction. So if we change the x-axis to sunscreen use, you get the same kind of plot, right? But actually, of course, before, maybe let's say 100, 200 years ago, sunscreen did not exist in the form in which we use it today. So as sunscreen is innovated, you get this, this gene-environment interaction is evolving over time, as the innovation comes through. And then, of course, it's not just stopping there. In the future, as we develop new techniques, not just for preventing, but maybe also for curing skin cancers once they appear. Of course, like this is kind of pushing the environmental range further and further. And this is a continual process, and it's much more rapid than ecological or genetic change. So you cannot just say gene-environment interaction and just assume that, okay, so here's the environmental range. Okay, maybe that's what we have now, but that's not the range that we had in the past. It's not the range that we'll have in the future. So it's very hard to generalize, not only across societies, but also across time of these interactions.
Mm-hmm. So rates of innovation and diffusion are one of those factors, right?
Yeah. So yes, if you think about how the gene-environment interaction changes as a function of cultural innovation and diffusion. So yeah, if some society, let's just assume for now, for simplicity, that some society is isolated, okay, that it cannot get innovations from the outside world. Yeah, if it has a slow rate of innovation, then yes, the speed of that change of the x-axis of the environmental range will be slower. And if diffusion is slow, then yeah, maybe some elite group gets to use this, and for them the environmental range expands. But for common people, it will remain narrow. And then if that happens, we also call this a cultural clustering. So there's more kind of the society is more so if you think about it as a network, it's more modular. So there's a module of elites that are more interconnected to each other than they are to the commoners, and then the commoners are more connected in the sense that there's more cultural influence among each other. Although of course there could be asymmetry where they're getting more from elites than flows vice versa. Yeah, in that case, then the heritability calculation also changes, right? Because if there's more variation in environments in that society by virtue of this network modularity, then the environmental variance component changes in the heritability equation. And so this is how all of this ties together with the calculation of heritability as well.
So this that is about environment interactions, but we also have gene-environment correlations in behavior genetics, like active, passive, and reactive gene-environment correlations. Are those also influenced by culture, or can they be?
Yeah, so gene-environment correlations. So let's just stick with the active gene-environment correlations for now, since I think they're the most relevant to culture. So of course, this is the sorting of genotypes to environments, where if you have some genotype, this doesn't necessarily. Okay, so it does predict your phenotype to some degree, and your environment also predicts your phenotype to some degree. But then some genotypes will sort themselves into some environments. I guess usually that match their abilities. So one example used by Flynn and Dickens is basketball. So if you have certain genes that predict skill in basketball, it could be height or it could be some kind of muscular structure. Then you'll probably gradually be pulled into environments that also help you develop basketball skill. Through physical education class in school and so on. And so it's not just what genes you have and what environment you're embedded in. The genes themselves will actively sort themselves into environments that help them express their potential. And so this can lead to things like higher heritability. This is interesting, and in our paper, it relates to a concept we call unmasking. Cultural unmasking of genetic potential, or unmasking of genes, of gene function. You also have okay. There's unmasking and masking. So masking corresponds to the kind of sunscreen example that I talked about. So if your site has sunscreen, then the association of the pigmentation gene with skin cancer risk is masked, right? And then unmasking, so there are some genes that predict competence in tonal languages, like Mandarin. And then if you are in a society that uses a tonal language, then of course this gene will be, or let's say that it has a mix of both tonal and non-tonal languages, then this gene will predict your competence. And so you can say that the language is unmasking the association of this gene with competence in Mandarin, let's say. Okay, so that's masking and unmasking. So active gene environment correlation corresponds to our unmasking. But at the same time, because it can also mask, we also have decorrelation. Let's call it that way. Okay, so we all know about gene environment correlation if you've read behavioral genetics, but you can also have decorrelation. And so this is what's happening with the sunscreen example, right? The normal gene environment correlation would be things like, so it's kind of similar to the basketball example, but if I happen to be good at perceiving and uttering tones, so, inflections in the phonology of sound in languages like Yoruba and Mandarin, then I will probably, I could sort myself gradually into environments that nurture that ability, and then it could lead to higher heritability. But at the same time, culture can also go in the opposite direction, where it's decorrelating. And so whichever direction you're talking about, culture has a large role to play.
So how is it that, for example, the causal effects of an identified gene can be confounded with features of the cultural environment?
So I guess it's pretty straightforward in some sense. So we can go back to the sunscreen example. So the causal effect of the pigmentation gene in predicting skin cancer. So this would appear as a skin cancer gene in societies that don't have sunscreen, right? So the causal effect of that gene is being confounded by the sunscreen. And so fundamentally, this comes back to sort of a more abstract idea that genes and culture are both operating within the same space of function, of biological function, right? So you can avoid skin cancer either by migrating north if you're at the equator, or by staying indoors, or not really at the individual level, but by being in a society that has norms for staying indoors when there's strong sunlight, or of course technologies like sunscreen. So the fact that there's this one space of how different biological functions could be realized, and then these could be achieved either through genetic adaptation or cultural adaptation. This sort of already logically ensures that you get this confounding of gene function with culture,
Yeah.
at least given the kind of analytic framework that we use in behavioral genetics.
I think we've already been touching a little bit on these issues, but what are some of the main issues with the generalizability of genetic effects across societies and time?
So the generalizability of genetic effects across societies has been a big topic of discussion, especially I think in the last few years, maybe last few decades. So the large majority of behavioral genetic studies has been done in the West, and it's really like a few countries that dominates. Like I think the U.S., the U.K., and Australia accounts for something like 2/3, just these three countries, of all twin studies, if I remember correctly. And you have a similar skew in GWAS, okay, even though that's more recent. And then it's just a matter of fact that when you try to use the same genes to predict phenotype, so if it's GWAS, in a society that's very different from the reference society, then it just predicts much less. So this also leads to problems like, okay, so since all of these genetic studies are done on Western populations, okay, when we try to develop medical interventions based on these, so people who have not been studied are at a disadvantage. So this is pretty well known. What's less well known, I think, is the difficulty to generalize genetic effects across time. So in cultural evolution, it's a given that culture is rapidly changing the phenotype by changing the developmental environment. And I mean, we all know that society changes a lot over the course of 100, 200 years. So if it's true that a lot of what we think of as just being gene function is actually confounded, and there's a large cultural force that's underlying these phenotypic effects, then it's a matter of course that since it's confounded, we know very well that culture, the change in culture over time is very likely to lead to difficulties in generalizability across time within the same society as well.
Is it possible to use the framework you present in both your thesis and the paper to predict how heritability would differ across societies, across socioeconomic strata, and other groups within the same society, but perhaps not others, and also across the lifespan?
So we can start from a pretty simple starting point that heritability is the variance explained by genes over the variance explained by environment. It's variance explained by genes over the phenotypic variance. And then so it's phenotypic variance in the denominator is variance explained by environment plus variance explained by genes. Okay, and so this environmental variance contains a cultural component. There's also ecology plays a huge role too, right? This environmental variance is what's changing rapidly, and also it varies across societies. The simple starting point I'm talking about is that you can simply look at which societies have more cultural variance. Within a society, you can also look at which substratum, maybe people in low SES households or high SES households have more or less cultural variance. So in our paper, we put forth the idea that people in high SES societies may have lower cultural variance because they're more interconnected among each other, whereas people in low SES households are less well connected and are kind of making decisions of what to eat, how to act, how to raise their children, not entirely on their own, but on a smaller scale, less connected across kind of global or broad swaths of society. And so this could be an explanation for the Scarborough effect, where because there's less cultural variability in high SES, then heritability would be higher. You can also look at compare countries, like I said, compare societies. So one thing actually that we did try is compare average heritability, regardless of phenotypes. So look across all phenotypes that are in the literature for twin studies in this case. And then you can look at a proxy of cultural variance. So the one we used is the variance in responses to the World Values Survey. Okay, and so if people respond to the World Values Survey in very different ways depending on the individual, then that's a high cultural variance society. So we're using those responses as a proxy of that. And if people tend to respond in a similar way on to questions about the economy, about religion, about food, and so on, then we would consider that a low cultural variance society. And so the prediction is that in the high cultural variance society, heritability will be lower because there's more environmental variance as well that comes with the cultural variance. And so that's the prediction. And so in a paper that is right now in preparation, we do find that there is that effect across all twin studies published between the mid 20th century to something like 2012, where the countries on the extreme of the cultural variance are places like Belgium, Australia. So a lot of multicultural societies are in there. Whereas societies that have less cultural variance, at least as indexed by the World Values Survey, is places like Indonesia, Pakistan, and so on. And so we do find this difference in heritability. So that's one not only a prediction, but also a result that it's not a huge effect, but it's a result that we found that comes out of this framework.
Mm-hmm. Would this also apply to a broader and better understanding of how weird psychology specifically evolved?
So I don't think there's a direct answer that this framework gives for weird psychology. Of course, it's a very interesting topic. I guess the most influential paper for this has been the one by Jonathan Schultz and Joe Henrik and their co-authors. So on their account, it's been the fragmentation of kin networks over the course of history in I guess in Europe that predicts weird psychology, right? So their proxy for that is years of exposure to the Western Church. I guess there's an Eastern Christian Church and a Western Christian Church, and originally the Catholic Church. And it seems like the countries that have been exposed longer tend to have more analytical thinking, more fairness towards strangers and not just kin, less holistic thinking, and so on. And so the idea is that the Western Church had this policy of breaking up kin networks. Mm-hmm. So this is really a kind of it's about cultural variance. So the cultural variance increases when you break up kin networks because now the smaller units, maybe it's a household, maybe it's a village, or are making their own decisions about how to act, what their norms are, what they want to eat, how to raise their children, and so on. And so so if linking it to the study that's in preparation that I just described earlier, we would predict that as the Western Church was implementing its family policies, heritability earlier I said heritability in general, I meant heritability for culturally transmissible traits. And the idea is that psychological and behavioral traits are culturally transmissible. So that's what we tested in the study. So the historical prediction would be that as the Western Church was implementing its family policies, heritability of culturally transmissible traits like psychology and behavior should have been decreasing. Of course, it's very hard to test this, but that's sort of one, I guess, link that you can make between the framework that I'm talking about right now and the evolution of weird psychology.
Mm-hmm. Would this framework also reframe the nature-nurture debate?
I think so. I think people mean different things when they say nature-nurture. It's kind of an intuitive notion. So I think a lot of the way people think about nurture is so I call it folk nurture. It's really driven by intuition. It's kind of a conception that you know, you don't have to be a scientist. You know, everyone, it just comes up in gossip too. So you know, you might hear in the village square people talking about, oh, you know, that person, you know, was raised by a single mother, or you know, that the person had a disease when they were young, and so you know, we think they're going to grow up this way. People have their folk theories about you know, how the environment will affect the phenotype, right? Behavior later in life, and so on. So that's sort of when I hear nature nurture, I think people often have that in mind implicitly. It's kind of anchored in these folk intuitions. So yeah, the environment, of course, but it's not just the way people think about it. It's a kind of a passive pipeline where experiences are coming through, and you know, the individual is just exposed to this world, which might bring good things or bad things. And then, you know, if you're lucky, you'll get a you know, good environment, and then develop in this, you know, you'll flourish and realize your genetic potential. But actually, on a cultural evolutionary account, experience is not really like that. The environment is not really like that. Because it's a lot of the environment is being transmitted through culture, through other people in our society. You know, imitation. It could be through you know, conformity to norms and so on. It's a much more active process, and it's you have this whole range of possible environments that is proportional to the range of behaviors that exist in your surroundings, in your society, and then you'll choose. You know, you'll use different kind of social learning strategies to say, okay, I really want to learn from this person. Okay, I'm kind of saying it in a conscious way, but of course it's not really deliberate. But for ease of explanation, it's really this kind of different process that is coming through this distribution of different types of behaviors and psychologies, and then you know, you are sorting yourself into some of them, and it's kind of a very different conception of how the environment unfolds compared to the way we think about it normally. So it really depends on what you mean by nature and nurture, but yeah, I think it does offer a different view on that.
So let us now get into the specific case of IQ and general intelligence. So tell us how your framework perhaps changes how behavior geneticists usually think about this issue.
Yeah, so of course IQ is a big topic in behavioral genetics. It's I think a lot of people don't want to talk about it because it causes so much controversy.
Yeah.
So for me, IQ is just well, you know, a lot of people would say this. It's just the ability to take a test and do well on these kind of analytical problems that appear on these tests that are, you know, kind of similar to the ones that you get in school, and probably also resembles ones that you get in white-collar jobs. Okay, one key thing to understand about IQ heritability is that even though it's often reported to be very high in adults, this is so no, the genes are explaining, you know, some part of IQ, and the environment is explaining maybe less. But this environment has culturally evolved, right? It's not just a given environment that is invariant across societies and across human history. In a society with like you know, much more you know, where parasites are a threat, or where there's not enough nutrition, or where there's war going on, there's much more environmental variance in factors that will influence IQ. You know, lead poisoning, you know, poverty. So, you know, we already know that there are a lot of studies showing that these factors influence IQ. So when we say that, okay, genes explain this much, we're comparing it to an environment that has already that has already culturally evolved in ways that typically, it's asymmetric. It's not kind of randomly moving around. It's getting rid of these threats that will result in lower brain function, lower intelligence, right? So it's really we're just talking about the residual after millennia of cultural evolution. So I think that's the most important thing to understand.
Mm-hmm. And what about the Flynn effect then? What would be the explanation for it?
Yeah, so the Flynn effect, the explanation would not be that different from the explanation that was given by Flynn himself, which is that he also views it as having cultural basis. So he would talk about how it's things like literacy, print media, video games, administrative work. So all of these things that are in our environment. And that are useful to be skilled in, correspond to the kind of ability that leads to good performance on IQ tests. Things like the Raven's matrices or vocabulary and so on. And so it's largely the same account. It's just that it's not kind of the technology level and sort of the things that are in our environment per se. It's also the networks of cultural transmission on our account that explains a lot of it. So Patricia Greenfield has this very nice paper which she talks about how there's this one village in the US in I think the early 20th century, and they did a bunch of IQ tests there. So they got a pretty good, it might have been a comprehensive idea about so how well their children were performing. And then shortly after that, there's this kind of a lot of roads starting getting built to the city. People began acquiring cars, and so access to the larger society became much more prevalent in a short span of time. And then when they tested IQ again, it increased a lot. Of course, it could be that their food became better quality. It could be any number of things that they were getting from the city. But one idea is that it's really the connectivity. The diffusion of the kind of skills that people were acquiring in the city became easier to acquire in the village as the connectivity of cultural influence became denser, and so it's not really just like the what kind of technologies are in the environment. It's also how the networks of cultural transmission expand, and how waves of diffusion and innovation change. So also if the rate of innovation increases, which it could as a function of not only connectivity but also things like the law, of course the economic situation, economic incentives, and so on. So all of these factors will increase rate of innovation, and then so as these diffuse sort of networks, so these all lead to an increase in intelligence in a world where white collar values are considered desirable.
Mm-hmm. So apart from intelligence, what other aspects of human psychobiological variation would the cultural evolutionary framework approach help explain? Do you think it would be limited to certain aspects of human psychology or not? Or could it apply to all of human psychology?
Yeah, so you're correct. I would say it applies to all of human psychology. That's sort of what I'm trying to get at. If you want to understand the mind or the brain, it's really okay. Of course, there's a strong like innate developmental program that does not change, not only in humans, but across species as well. Highly conserved over millennia. But at the same time, there's the kind of neurodevelopmental input that we are getting is heavily shaped by culture for humans. So we are not only designing tools and practices and such. We are designing our neurodevelopmental input, right? That's effectively what's happening, and so it's the whole of psychology that needs to be recast, understood in a different way once we think of it through the perspective of cultural dynamics, population dynamics.
Mm-hmm. So just one last question and a specific example, because in personality psychology, people, at least in the Western world, have been focused have been focusing very much on inventories like the Big Five and the Hexaco. Do you think that we can improve our understanding of personality and perhaps personality variation with this framework in mind?
Yeah, so I don't know so much about personality, but one interesting paper that came out a few years ago was one by Paul Smaldino and Aaron Lukaszewski, I think that's the name, and Mike Gervin. So this was based on an earlier paper that Aaron and Mike Gervin had published that shows that in some hunter-gatherer societies, it's not a big five, it seems to be a big two. It's a two-factor structure that best explains their personality. And so why is this? Of course, Big Five was first developed in the West. And so this recent paper was a model suggesting that it could be what they call niche complexity. So in societies that have many different kinds of situations to adapt to, whether you're at the market or getting getting food on the farm, but in school in a different situation, trying to analyze a movie in a different situation. So at least this is how I'm understanding it. If you have these kind of different cognitive and I guess affective niches, then it's really that the more niches you have, the more multifaceted personality structure tends to become. So yeah, I think this is a really interesting approach. In terms of something like heritability of personality, this would suggest that in societies that have inequality in niche complexity, where some people have very multifaceted intellectual and emotive lives, and whereas other people are, this could be relevant as work from home and automation of work becomes more prevalent. Then there are people who are just going to be working at their computers, there are already all day, and so they might be doing very complex work on their computer, but it's monotonous from this niche complexity perspective. And maybe personality structure will be influenced by this, right? Over generations, or I don't know how much of it is cultural transmission and how much of it is direct experience of these niches. But you could predict that in a society that is inequality in niche complexity, heritability of personality would be more explained by the environment, so a decrease. So that's one prediction that you could make about personality.
Mm-hmm. So Ryutaro, just before we go, would you like to tell people where they can find you and your work on the internet, and also if you want to tell us the kinds of things you're working on at the moment, and perhaps what specific aspects of human psychobiology you would like to apply this cultural dynamics framework to?
Sure, yeah. So I'm on Twitter. My Twitter account is @Ryutaro Uchiyama. I guess my name, the spelling should be somewhere in the YouTube video. My website is uchiyamaryutaro.com. I'm from Japan. In Japan, actually, that's the proper order. You start with family name and given name. Yeah, so I've been talking about genetics today. My background is not in genetics. I did cultural evolution for my PhD, but before that, it was in cognitive science, neuroscience, and behavioral biology. Mm-hmm. So some of what I said about genetics, it might be a bit rough around the edges. Hopefully, I haven't made some critical mistakes. But what I'm trying to do right now is to find a way to merge, like what I said in the beginning, with a cultural psychobiology, take the cultural evolution framework and try to integrate this with behavioral biology. Cognitive neuroscience is something I'm very much interested in, and right now I'm doing more the cognitive and neuroscience side. In Singapore, I'm involved in a project that studies adolescent development, in particular executive function, and a construct called cognitive flexibility, how this is influenced by different cognitive abilities as well as socio-emotional abilities. So we go into local schools and test 13-year-olds on a battery of cognitive tests. And then I guess in the near future, I'd like to try to merge this the cognitive side with the cultural evolutionary side. So that I guess that's where I am now and where I'd like to head.
Okay, great. It's been a real pleasure to have you on the show, so thank you so much for accepting the invitation.
Yeah, thank you very much, Ricardo. It was nice talking to you.
Hi guys, thank you for watching this interview until the end. If you like what I'm doing and to help me keep the channel sustainable, please visit my Patreon page or PayPal and consider making a pledge there. Otherwise, and if you like what I'm doing, please share the interview, leave a like and hit the subscription button. The show is brought to you by Enlights, Learning and Development Done Differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters, Karen Litska, Anne Blanchett, Parago Larsen, Lau Guerrero, Francis Ford, Hans Frederick Sunda, Ricardo Vladimiro, Craig Healy, Adam Castle, Olaf Alec, Jonathan Wissel, Jacob Klinkby, Matthew Whittingbird, Arno Wolf, Tim Hollesy, Henrik Alenia, John Connors, Paulina Barron, Philip Force Connolly, Jerry Mueller, Herbert Gintis, Rutger Vos, Bo Weingard, Rebecca Newberger, Goldstein, Dan Demetriou, Robert Windager, Rui Inácio, Arthur Coe, Zup, Marco Neves, Colin Holbrook, Susan Pinker, Bernardo Seixas, Pablo Santurbano, Simon Colombo, Jorge Espinha, Phil Cabana, Mark Blythe, Roberto Iguanzo, Michael Stormir, Eric Neumann, Samuel Andreev, Tiago Nunes, Bernard Ugni, Alexander Dunbauer, Fergal Cusson, Evan Bodrenko, Hal Herzog, Don Ross, Jonathan Librand, Oslam Bullitt, Nathan Nguyen, Stanton T, Samuel Correa, Eric Hines, Mark Smith, J.W., João Eira, Tom Hummel, David Sloan Wilson, Yacila Deza Araújo, Eden Solon, Romain Roach, Dmitry Grigoriev, Diego Londonio Correa, Tom Roth, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavel Ostazewski, Nelek Bach, Catherine and Patrick Tobin, Al Ortiz, Guy Madison, Gary G. Hellman, João Linhares, Lida Cosmides, Saima Afzal, Adrian Yegi, Nick Golden, Paulo Tolentino, João Barbosa, Jules Price, Edward Hall, Edin Bronner, Franca Bortolotti, Gabriel Pons Cortez, Ursula Litska, Denise Cook, Scott, Zachary Fish, Tim Duffy, and Todd Shackelford. My producers Cesar Webb, Jim Frank, Lucas Stafinia, Kian Gilligan, Luís Caetano, Tom Vanagdam, Curtis Dixon, João Linhares, Benedict Mueller, Vega Guidi, Sardas France, Thomas Trumbull, and Nuno Welder. And my executive producers Michel Rugieski, Rosie, James Pratt, Matthew Lavender, Sergio Quadriano, and Bogdan Kanivets. Thank you for all.